Hi guys, so we're looking at day 9 today. So today we are looking at lessons 50 and 51. So let's go ahead and get turned in our books. Lesson 50. So we're using unit multipliers and unit conversions. So this is where having your reference sheet in front of you, because if you don't remember how many feet are in a mile or how many inches are in a foot or whatever it is, quarts or in a gallon, it's going to be difficult to convert. So having those in front of you, I don't expect anyone to have those memorized, but having those is what we're going to use when we use a unit multiplier. So again, we've worked with canceling fractions, prime factorization, greatest common factor, reducing fractions, all of those things. When we're canceling something out, any number over itself, whether it's directly over or it's eventually going to be in the numerator and in the denominator, we know that we can cancel it out. We get rid of it and it becomes 1. We usually don't write it in because 2 times 1 is 2, 1 times 5 is 5. So we just say 2 and 5, so 2 over 5. Okay? But it's the same thing we can cancel out when we have the same units in the numerator and denominator. So feet over feet, well, feet divided by feet, just like a number divided by itself, cancels out to be just 1. So that's how we're able to cancel and be left with some of these. So we do some of this without even realizing what we do. If I said how many inches are in 5 feet, you may just say, well, 12 times 5, which is 60. That's correct. There's 60 inches in 5 feet. And when we're doing that, what we're doing is we're saying 5 feet times 12 inches over 1 foot. Feet and feet cancel out. 5 times 12 inches is 60 inches over 1 is just 60 inches. So it's something we do kind of without even realizing that's what we're doing. But as we get into where we're canceling out multiple units or we're converting, then converting again, understanding this idea of unit multipliers is going to make life a lot easier. So what a unit multiplier is, it's just something that's equivalent to 1. So 12 inches is equivalent to 1 foot. So 12 inches over 1 foot, if I multiply something by that, I'm still multiplying it by 1. I may be obviously converting the units, which is what we want to do, but I'm not changing it. So 60 inches and 5 feet are the same distance. It's just different units that we're using to measure them. So that's where we use our unit multipliers. Okay, so the same one we talked about. Okay, well, 12 inches over 1 foot, that's still equivalent to 1. 5 times 1, or 5 times, in this case, 12 inches over 1 foot, leaves me with feet and feet canceling out. 5 times 12 inches is 60 inches. Okay. So whatever our given measure is, times our unit multiplier is going to give us our converted measure. So 2 unit multipliers we could use for the equivalency of 3 feet equals 1 yard. We can write it both ways. 3 feet over 1 yard. Well, 3 feet and 1 yard are the same thing, so that's still 1. Or we could flip it, just like 2 over 2 or 2 over 2. They're both 1. Anything over itself is just 1. So we can write it as 1 yard over 3 feet, and that's another unit multiplier, and it's still equivalent to 1. All right, so for converting 240 yards to feet, (240 yards), we want to end up with feet. Okay, well, I want yards to cancel out, so I know yards are going to be down here. So feet are going to be up here because I want to end up with feet, and I want yards to cancel out. So 3 feet equals 1 yard. That's my unit multiplier. Yards and yards are going to cancel out. 240 times 3, that's going to be that's 720. 720 feet. Let me write it a little neater. Okay. So it depends on what we're trying to end up with and what we're trying to cancel out. The reason I didn't do yards over feet, that would give me square yards over 3 feet, and that would not help me at all. That would make it much more complicated than just writing it out as we originally had it. So we want to get rid of yards, and we want to end up with feet. So that tells us which unit multiplier we use. Tim can sprint 9 yards per second. Convert this to feet per second. Okay. So we have 9 yards per second. That's the rate that he's traveling. And we want to convert that. Okay, so we want to get rid of yards and we want to end up with feet. So we do 3 feet over 1 yard, and then 9 times 3 is 27. 1 second times 1 is 1 second. So 27 feet per second. Right? Well, down the road, we may have something where it's miles per hour, and we want to know, well, how many feet per second is that? Well, then we're going to have to convert miles to feet, and we're going to have to convert hours to minutes. So we may be doing more than just one conversion down the road. So that's where having these unit multipliers can make life a little bit easier. Okay, practice set we'll go over. Just remember, unit multipliers are equal to 1. So know which units. Obviously, if you don't know, there's 3 feet and 1 yard. It may give it to you. You may have to look back at some of these and say, well, how many ounces are in a pound? It's obviously right there, but you may not remember that right off the top of your head, or how many feet are in a mile, or we can even convert from metric to standard and back and forth. How many inches are in a meter? It's not one we typically use, but we can go through and convert and use a unit multiplier to figure that out. Okay, investigation 5, we may do that. Okay, lesson 51. So we're jumping ahead to lesson 51 just because I want to make sure we have a full day to go over the review. And normally, we do the review. I didn't want to do the review and a lesson just because then we wouldn't have much class time to work on the review. And I didn't want to do the review before we did lesson 50 because then you're going to be tested on things that we maybe haven't seen in the book yet. So we're kind of doing things a little bit out of order, but it's for your benefit. So we have more time to look at the review. So scientific notation for large numbers. So scientific notation we've worked with before. We know we're taking a decimal number. Okay. We have something in the ones place and then everything else to the right of the decimal. And then we're multiplying it by 10 to whatever exponent, depending on how many times the decimal place moved to get us to where our coefficient is now. That's the number that appears up there. Okay. Positive exponent means it's getting bigger. The decimal is moving to the right. If it was a negative exponent, which we can use scientific notation for really small numbers, then it would be moving to the left. Okay, so we're not changing the value of the number. We're just rewriting it in a way that makes a little bit more sense. For small numbers, like 2, I would much rather write 2 as just 2 than 2.0 times 10 to the power of 0. That doesn't really help us any. So it's really beneficial when we get to some larger numbers, but we can still, just for practice sake or just whatever, we can write 2 as 2 times 10 to the power of 0, because if I have 0 for my exponent, that means this decimal place moves 0 times. 10 to the power of 0, any number to the power of 0 is just 1. 2.0 times 1 is 2. So again, it seems like a lot more work to just make it more complex, but we could write it as a scientific, any number we can write as a scientific number. 24 millimeters, 2.4. Again, this coefficient right here has to be, 1 or greater, and it has to be less than 10, because we can't call it 24 times 10 to the power of 0. We call it 2.4 because this coefficient, we have to have a value in the ones place and then everything else to the right of the decimal, whether that's a 0, 4, if we have 5 numbers to the right of the decimal, it doesn't matter. It has to be greater than 1 and less than 10. Okay, 1.6 times 10 to the power of 2, so that would mean I move the decimal 2 places to the right to give me 160. 4.5 times 10 to the power of 3, well, I move it 3 times to the right, which is 4,500. Okay, 1.6 times 10 to the power of 6, I move it 6 places to the right, which is 1,600,000. So this is just showing you if we want to calculate a marathon or a mile or something like that in millimeters, we probably wouldn't want to get out there with a ruler, probably wouldn't want to do it. I don't know why we would want to have these large distances in millimeters, but we could. Obviously, the distance of a marathon is 20 some miles, so that's going to be a lot of millimeters. So if we want to express that versus writing out, and this is used for really, really large numbers, we're getting beyond millions and billions and trillions, where we have, if we have a coefficient and then 20 zeros that follow it, we can write it out, but it's probably going to be easier to use scientific notation to write it. So let's take a look at example 1. There are 8.864 times 10 to the 4th seconds in a day, or 8.64 times 10 to the power of 4. Show this number is written in scientific notation. So 8.64 times 10 to the power of 4. Okay, so we write it. That's our coefficient. Always base 10 because we're moving decimals. So it's 1, 10, 100, 1,000, or if it's negative exponent, we're talking about tenths, hundredths, thousandths, 10,000ths, and moving the decimal to the left. So if we're working with this and we want to write it in standard form, 2.46 times 10 to the power of 8. Okay, so what I do is I just rewrite my coefficient. Okay, again, with the decimal, I would always, anytime you work, we want to show our work. I know it feels like we're just doing that because teachers have always said, show your work, show your work. It gets more and more important as you get into more complex mathematics, doing, trig or pre-calc or calc or something like that. Even algebra in your head is going to be very difficult to do. Sometimes you can, if it was just 2 decimal places, yeah, you could probably do that in your head. But let's get in the habit of best practice. I always rewrite the number, and then this 8 tells me that it's a positive 8, so the decimal is moving 8 places to the right. So what I do is I actually draw out 1, 2, 3, 4, 5, 6, 7, 8, and then that would be my new decimal, and then fill in the zeros wherever they are. And then we could rewrite it down here if we wanted to, 246 million. And we don't have to include the commas. It just kind of helps us as we're reading the number out loud, or if we're trying to figure out place values to separate it into these hundred, thousands, millions, billions, trillions, can help us navigate a little bit faster. Okay, so let's look at one where we're trying to work backwards. So we have 40,720,000. So 40 million. Okay. So again, I know that I want my value to be greater than 1 and less than 10. So I know it's going to be 4 is going to be my 1's value. So 4 and then 0.0. Okay, but then there's more non-zero numbers to the right of it, so I have to include those. So 4.072, then it's all zeros, so I don't have to keep filling in zeros. That would obviously defeat the purpose of scientific notation because it would take up more room. So 4.072, and then to get the decimal here to here, I had to go 1, 2, 3, 4, 5, 6, 7 places. So that tells me that 10 is being raised to the power of 7. So if it's a 0, that's just 1. So it's just that number. The decimal place moves 0 places. 1, it moves 1 place. 2, at 2 places. 3, 3 places. All the way to 7, it's moved 7 places. So kind of the opposite of what we did. Okay, then we could check our work by multiplying this out. 1, 2, 3, 4, 5, 6, 7 decimal places, and we would end up where we started.